Welcome back. A warm welcome to you. So in the last video we have seen about the distance between the 2 points. We have derived the formula for distance between 2 points, and we have also applied the concept with the help of some examples. In this video we will see some of the equations of straight lines and see some simple examples on them. In the next video and coming videos, we'll be going through all the equations of straight lines. Then we'll go through the sums grading from simple to complex. So let's start with simple equations of straight lines. There are so many forms of straight lines. In this video, we'll be covering gradient form, or you can say it as slope form, slope and intercept, we'll also see two intercept form. Slope-intercept form, two intercept form, slope or gradient form, where it passes through horizon 0, 0. So we'll see these three equations in this particular video. We will also see some simple examples on them, and we'll continue to the next video. So let's go ahead and see how to derive the equations for these one after the other. Let me start with the slope form. Slope form says that you have to find out the equation of the line. We have to find the equation for the line given slope and also that it passes through horizon. The line passes through horizon. Okay. Now I'll erase this part so that I can find the equation. Okay, that should be fine. Let's go back. Let's say I have been given the equation of the slope. As I said earlier, all these equations of straight lines revolve around one basic concept. The concept is, if I have a straight line, how can I find out the slope of a straight line? How many points I need? How many points I need to know the slope of a straight line? I need 2 points. We have seen that already, right? y2 minus y1 by x2 minus x1. Just remember, those are 2 points on that particular line. There are infinite number of points on that line. To form the equation, always our approach will be to take the slope or whatever the points we have been given, and also take a arbitrary point x comma y. Now leveraging this point and equating the slopes, we will be finding out the equation of the straight line. Let me repeat again here. Suppose I have a point here x1 comma y1, and I have been given the slope as m. I am not going to actually derive the equation, I am just trying to explain this. We know that m is nothing but equal to y minus y1 by x minus x1, right? And you have been already given the slope. That's nothing but one type of equation. So that's nothing but one type of equation where you have been given one point and you have been given slope, which we say as slope and point slope equation. Now the whole point I am trying to drive home here is that the whole concept of equations always revolves around one single point, that is, my slope is always constant for the line. So that means if I am able to find out the points on the line, then if I can equate them by this formula, and to be generic, delta y by delta x, because I don't know whether they are y1s or y2s, what I mean to say, delta y by delta x is always constant for a line, because that's nothing but slope. And you know slope of a line will not change because you are not bending, it's a straight line. So that's a whole concept. Okay, with that, let's move ahead. Okay, now let's see the equation for the first one. So this is my coordinate, this is my x-axis, and this is the y-axis, both of them in positive direction. Now I have to find out the equation of a line which passes through origin. That means this is origin, so I have to find out a line which passes through origin, and it's having a slope of m. So I have been already given that the slope is equal to m, right? Now when it passes through origin, I know, see, always the effort is to find out the points on the line so that equate it to the slope, because we know slope is given as m, but that is also equal to delta y by delta x. If I am able to find out 2 points, then I can equate it to m. So I know one point here, it's already given that it passes through 0, 0. Now another point to frame the equation, I am going to take it as x comma y. Now let's forget that I have been given the slope. Now what is slope? If I know 2 points, is nothing but equal to y minus 0 by x minus 0. This makes sense, right? But this is already given as m. So that gives me y equal to mx. This is nothing but the equation of the straight line passing through the origin with slope m. Let me repeat it again. With respect to the straight lines, always the effort is to find out the points so that either you can find out the slope or you have been already given the slope, then equate whatever the delta y by delta x you get to the slope so that you can frame the equation. And we'll be also always considering xy as a point, because any point which satisfies any x value, for any x value, if you have the slope, you can find out the y. That means any points ordered pair. What I mean to say is, if you know the slope, you can find out the ordered pair, or you can find out all the points across this line. Suppose I take x equal to 0. If I know slope equal to 1, y equal to 0. If I know x equal to 2, if slope equal to 1, I know y equal to 1, 2. So that's nothing like making 45 degrees angle, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, etc. Okay. Now let's jump to the next equation. I think this is pretty much clear. No problem here. But if so, I think I can clarify you again when we are going through the examples. Now let us see a little bit extension of whatever we have done. If you remember, what we did in the previous example is, we have we have coordinate axis. This is x, this is y, this is x, this is y, and I have been told that a line is passing through the origin. Now instead of that, this equation, whatever we are referring to, let me just give that before. What we are referring to now is slope-intercept form, where intercept is y-intercept. Now before that, let me explain you what is the intercept. Here it's y-intercept. The form is slope-intercept form. Now suppose you take a straight line. That's not a straight line. This is okay. Suppose you take a straight line. It is intercepting x and y axes at some particular points. The length of these points from origin, that is nothing but this and this, are known as intercepts. This is x-intercept and this is nothing but equal to y-intercept. Now this is clear. That's about the intercepts. So if you take a line, if the line is intersecting with x-axis and y-axis at a particular point, the length from origin to that point, that means the x-axis distance, is called as x-intercept. Similarly for y, it is y-intercept. Okay, let's go back. Let me draw this again for this particular equation. Okay. Now we know what is intercept, and I said here it is y-intercept. Okay. This is my x-axis. This is y-axis. I have been given y-intercept. That means the line is making intercept. So I say the line will go like this, or it will extend in the direction. But we know that this intercept is given to us. Let us say that slope is m and intercept is c. So I know this length is equal to c. This is my origin, and I have been given the slope of the line as m. Now as I said earlier, always our effort is to find out points so that I can equate it to the slope. So let us see, with the help of whatever the information we have, can we find out one point, because I always have x comma y with me to find the equation. If you see here clearly, if you are making an intercept of c, this point coordinates are nothing but what is the x coordinate here? 0. So this is 0 comma c. Now we are back. We know there are 2 points, 0 comma c and x comma y, and we can find out the slope. What is the slope? Slope is y2 minus y1, that is y minus c, by x minus 0, right? None, but that's nothing but equal to given to us as value m. M is a number which is given to you. So if you equate this, you get mx equal to y minus c, which gives me y equal to mx plus c. This is the equation for slope and intercept. This is your slope and this is the intercept. Slope, y-intercept. I think you are pretty much clear with this. Let me repeat. I don't think so, right? Only the thing is, earlier it's passing through origin, so the point is 0, 0. Now it's making an intercept. That means the coordinate is changed, but the remaining all are same. Now I have the point instead of 0, 0 as 0c. Once I know it's a 0c, I have always x comma y with me. I can equate with to the slope whatever is given to me. So m slope is already given, but that's equal to delta y by delta x. That's nothing but difference of y coordinates by difference of x coordinates. Here y minus c by x minus 0. So if I simplify this, I get y equal to mx plus c. Now we have seen the first case passing through origin. Second case, we went a little bit up in upward directions and we have seen intercept with respect to y. Now let's take the third equation. That's nothing but equation of the straight line with two intercepts where I have both x-intercept and also y-intercepts. Let's move ahead. I think it will be pretty much clear if we do a couple of examples. But just remember, this is very easy once you get the concept of slope. And remember that all our effort is always to find points and find the slope or equate the given slope to whatever the value you get or whatever the equation you get. Let's take the last equation, then we will do a couple of examples. I'm sure it's going to be pretty much interesting. So let's go ahead. Okay, now let's again go to the third equation. What is this equation is called? I said this equation is two intercept form because I have been given intercepts a comma b. This equation is called two intercept form. So there is a straight line. Super, I got it perfect. Now this is my x-intercept. As I said earlier, this is my y-intercept. This we have discussed earlier. What's the meaning of x-intercept and y-intercept? The points where the line is intersecting the x coordinate x-axis and the y-axis. Okay. Now I have been given only this, nothing else. But in these 2 points itself, I have additional information. Can you find it out? Yes, you are absolutely right. You know that these point coordinates are nothing but a comma 0. Why? Because it's on x-axis. On x-axis, y coordinate is 0. So I know this point. Similarly, can you find out this point coordinates? You are in y-axis, that means your x-axis is x-coordinate is 0. So this is nothing but 0 comma b. Now it's pretty simple. I have 2 points. I can find out the slope. Once I find out the slope, what I can do? I can apply my slope-intercept formula, whatever I have done earlier. So let's see how this is interesting going to be. Now what is slope? Slope equal to m is equal to y2 minus y1, that's 0 minus b by x2 minus x1, that is a minus 0. That's nothing but minus b by a. Now what is the, you remember, just forget about what's happening here, just only look at this. You know the slope now because we have just found that slope equal to minus b by a, where AB are my x comma y intercepts respectively. And you also know the equation for the line where you have the slope and also you have the y-intercept. This we have done just 5 minutes before. What is the equation for this? Y equal to mx plus c. I hope you are with me. This is what we have done just 5 minutes before. The equation just before this equation. Now y equal to, what is m? Minus b by a x plus c. What is c? C is nothing but y-intercept. In this case, it is equal to b. Are you with me? So, if I simplify this, this becomes ay equal to minus bx plus ab. Or, if I bring bx to this side, becomes transposing bx plus ay equal to ab. If you divide by ab, the whole equation, it becomes x by a plus y by b equal to 1. This is the equation. this is the equation for finding out finding out the straight line equation if you have been given intercepts a comma b. So let's summarize all the equations of straight lines what we have learned just before. Let me just clear this so that we can start fresh. Now what we have learned in this video? We have learned three equations. The first equations where I know slope and the straight line passes through 0, 0. What is the equation? Y equal to mx. This is gradient form. Now the second equation we have find out is y equal to mx plus c, where c is the y-intercept made by the straight line and m is the slope of the straight line. This is called as slope-intercept form. And if you observe clearly, if my intercept is 0, then automatically this becomes y equal to mx. What I am saying here, if I have a straight line which is making intercept c, my equation is mx plus c. If this comes down and becomes like this, it becomes y equal to mx. Now can you see the slopes are same? Because they are parallel lines. Okay. So let's move ahead. What else we have seen? We have seen x by a plus y by b equal to 1. This form is known as two-intercept form, where a comma b are intercepts made by the straight line on x comma y axis respectively. Now let's see some interesting examples. I'll just keep these equations as it is so that you can use them. Okay, let's take a simple example. As I said earlier, we will start with simple examples, and once we cover all the equations, then we can make it a little bit complex. Okay, this is our first sum. Equation of the line with slope equal to 3. So I have been given m equal to 3. Find out the equation of the line with slope 3 and making intercept of 5 on y-axis. Now what is intercept on y-axis? C. C equal to 5. Can you frame the equation? Pretty simple. Y equal to 3x plus 5. So simple. Let's take another one. This is interesting. Find out the equation of the straight line which is making an angle of 135 degrees with positive direction of x-axis in anti-clockwise direction. That means theta is equal to 135 degrees. What we call it as inclination, right? Now, and also given that my y-intercept is equal to 3. That's nothing but c equal to 3. Now, how to approach this problem? I think you remember m equal to tan theta. I'm sure. Tan theta is nothing but tan 135. And we know that's nothing but equal to tan 90 plus 45. That is nothing but equal to minus of cot 45, which is nothing but minus 1. So this is another way of saying m equal to minus 1. Once I know m equal to minus 1 and c equal to 3, it's very straightforward. Y equal to m minus 1 into x plus c equal to 3. That's nothing but x plus y equal to 3. I have simplified and moved it this side. Let's go ahead. We'll see some more examples. Okay. We'll take one more example and we'll stop. We'll continue in the next video where we will go through some more forms of straight line equations. Now let's do one sum on two intercept form because we haven't touched it till now. So let's do this. Find out the equation of the straight line which is making 5, 6 as x, y intercepts. Find out the equation of the straight line which is making 5, 6 x, y intercepts respectively. That means a is 5, b is equal to 6. Now what is my equation? X by 5 plus y by 6 is equal to 1. Simple and straightforward. 6x plus 5y equal to 30. Let's see one more. I'll erase this. Okay. Let us take a little bit more interesting problem before we close this session. So this is the last sum for this particular session. Find out the equation of the straight line. This is with respect to two intercept form. So you'll be using this formula x by a plus y by b. Find out the equation of the straight line which has been given that the sum of the intercepts of a line is 7. Sum of the two intercepts is equal to 7 and the product of the intercepts equal to 12. Find out the equation. Now if I know a and b, I can substitute, but they are not directly giving to me. I have been asked to simplify a simple expression. A plus b equal to 7, ab equal to 12. Now you can solve this by a plus, I can just out of intuition say that it's 4, 3 because 4 plus 3 is 7 and 4, 3 is 12. Another way of doing it is a plus b. B is nothing but equivalent to 12 by a is equal to 7. So a square plus 12 is equal to 7a. A square minus 7a plus 12 equal to 0. If I simplify this, a square minus 4a minus 3a plus 12. I think this is nothing but splitting the middle term. You are with me. Minus 7, if you add them, multiply, it should be 12. So minus 4 and minus 3 adds up to minus 7. If I multiply, it becomes 12. Now let's take common here a. This becomes a minus 4. I can take minus 3 here so that I get a minus 4 again. This gives me a minus 4 into a minus 3 equal to 0. Nothing but my a equal to 4 or 3. If my a is equal to 4 or 3, b will be equal to 3 or 4. So let's frame equations for 4 or 3, 3 or 4. Let me just erase this part so that I can complete the problem here. Okay. Now x by a is nothing but, let us take a equal to 4. X by 4 plus y by 3 is equal to 1, or if a equal to 3, this becomes x by 3 plus y by 4 equal to 1, which you can simplify. Let me just do it for the sake of completeness. This becomes the next equation. Next step of these equations will be 3x plus 4y equal to 12, and also 4x plus 3y is equal to 12. These are the two equations. I think you got it. You took LCM here. So 3x plus 4y, move it there, 12. Similarly here 4x plus 3y equal to 12. We'll stop here. In this video, we have seen couple of forms of straight line equations. We have seen the gradient form, we have seen the slope-intercept form, and we also have seen two intercept form. Intercept is nothing but a point where a straight line is intersecting a coordinate axis. If it is x, it is x-axis. If it is y, it is y-axis. We'll stop here. In the next video, we will go through some more types of equations. Thanks for viewing. Bye for now.